The question asks us to find the rate of change or to find the instantaneous, which means at the moment, rate of change or the derivative or the slope of tangent line. Then for all of these cases, we can use one of two equations. We can say f prime of a is equal to the limit of h approaching 0, f of x plus h minus f of x over h. And we can also say f prime a is equal to the limit of x approaching a, f of x minus f of a over x minus a. Okay, let's apply an example for you. And in this example, I'll be referring to the second method. Here's the example. Find the slope of tangent line to the graph of f of x is equal to x squared at the point of -2 and 4. So I'm going to say that the slope is equal to the limit of x approaching the value, which is the -2, f of x minus f of a over x minus a. So the limit of x approaching that value, f of x being x squared, f of a being -2 squared, and x minus a, which is -2. So we'll get the limit of x approaching -2, x squared minus 4 over x plus 2. Now it's time to factorize, and there's a rule in math that says a squared minus b squared can be factored into a minus b times a plus b. So I'm going to say limit of x approaching -2, x minus 2, x plus 2. The whole thing is x over x plus 2. Cancel them. And now it's time to replace. So instead of x, I'll put -2 minus 2. So I'm just going to be replacing essentially inside this remaining part. And I will be getting myself -4. That's the slope of the tangent line. Okay. Now, what the question can do is that it can extend to the following. The question could say find the equation of tangent line at -2 on 4. The equation has to be y minus y1 is equal to mx minus x1. This is my x1 and this is my y1. So we're going to say y minus 4 is equal to the slope. The m we already found to be a -4. So a -4 x minus -2. So y minus 4 is equal to -4x plus 2. Now it's time to expand on the right side. We'll get -4x minus 2. So y is equal to -4x minus 2 plus 4. Y is equal to -4x plus 2. That's going to be the equation of the tangent line. Now the question can be expanded to find the equation of normal line to the same function at -2 and 4. Normal line just means perpendicular line. That means that the slope prior was found to be -4, then the normal line is going to have a slope of the negative reciprocal of that. So the negative, okay, of 1 over -4, and we get 1 over 4 as the slope of the normal line. So we're going to say y minus y1 is equal to the slope of normal line, which is 1 over 4, x minus x1. Y minus 4 is equal 1/4 x plus 2. It's time to expand 1 over 4x plus half. This -4 goes to the right side, becoming a positive 4. Y is equal 1/4 of an x plus 4.5. That's going to be the equation of the normal line. Great. So now let's move on to a different question that asks for finding the rate of change. So the question says, find the rate of change of the function f of x is equal to x squared minus f of minus 5x at c is equal to 2. I could be using this equation that the f prime of c is equal to the limit of x approaching c, f of x minus f of c over x minus c. Now, don't freak out. This is the same equation we saw earlier. We said f prime of a is equal to the limit of x approaching a, f of x minus f of a over x minus a. Same exact equation, but now instead of a, we just use c. All right, so it's time to replace. So this will be 2. Every c is going to turn to a 2. And now let's continue. The limit of x approaching 2, x minus 2. F of x has to be x squared minus 5x minus f of 2, which is going to be 2 squared minus 5 times 2. We'll get the limit of x approaching 2, x squared minus 5x minus 4 minus 10, and 4 minus 10 is negative 6, so minus negative 6 is positive 6. And now it's time to factor the numerator. We'll get x minus 3, x minus 2. Cancel out these guys and replace the x with a 2. So 2 minus 3, which is equal to negative 1. That's going to be our answer. So far I've been working with this equation to be specific. Okay. Now it's time to show you how to work with the first equation. Okay. Let's go ahead. In this question it says, find the equation of tangent line to the y is equal x squared at 1 and 1. That's going to be our x1. That's going to be our y1. Right now it's your job to find the slope. We can use this equation to find the slope. So we're going to say the limit of h approaching 0. Instead of of the fx plus h, we'll just put x plus h squared minus f of x, which is just x squared. Okay. And now it's time to expand. You see, I would reserve this method for like a single x term, okay? And I would reserve the other method for a term involving more than one x term. So right now, if you have a single x term, I recommend using this method. And if you have 2 x terms or so, you can use the other method, okay? Now let's go back here. So x squared plus 2xh plus h squared minus x squared, okay, over h. The x squares will cancel out. And now we can simply factor out the h. 2x plus h over h, cancel the h's, and replace every remaining h with a 0. So 2x plus 0. And you get 2x, x being a 1. So 2 times 1 is 2. That's going to be our slope. Okay. And let me just show you how we can find the slope, which we just found using the other method. Okay. To get an idea of how they compare. So I'm going to say the limit. Now I'm going to be using the second method to find the slope. The limit of x approaching, in our case, a 1. F of x minus f of 1 over x minus 1. So the limit of x approaching 1, f of x is going to be x squared minus 1 squared x minus 1. 1 squared is just a 1. And now if you recall, when it comes to factoring, we have a squared minus b squared is equal to a minus b times a plus b. So I'm going to do that. Limit of x approaching 1, x minus 1 times x plus 1 over x minus 1. Cancel out and you get x plus 1. Instead of x, just put a 1. You see? You get the same exact slope. You still get it too. Okay. Now, the question wants to find the equation of tangent line. So you just have to say y minus y1 is equal to mx minus x1. y1 being a 1, m is the slope. And now y is equal to 2x minus 2 plus 1. Y is equal to 2x minus 1. And we got it. Okay, here we have f of x is equal to x cubed minus x. They want the formula for the f prime x. So we can do limit of h approaching 0, fx plus h minus f of x over h. Okay. Now, do you guys know how to open the brackets? So if I have x plus h cubed, do you know what you get? X cubed plus 3x squared h plus 3x h cubed, h squared plus h cubed. Okay, so please take a note of this so we can move on to the next part. Okay, now, assuming you guys took notes, I want you to do the x cubed separately from the x. Does that make sense? We'll combine them later. So for now it's saying illustrate by comparing the graphs of f and the graph of f prime. F prime was 3x squared minus 1. So you're given the graph of f, which is this one. You're supposed to turn it into this one. Let me show you how. So guys, f prime is the slope of f. So for example, how much is the slope here? So take a horizontal line and place it at the maximum. How much is the slope of a horizontal line? 0. That means your f prime must have a 0 at that point. And again, place a horizontal line at the valley whose slope is going to be again 0. Now, let's talk about the left. So here we are rising. If we are rising, should our slope be positive or negative? Positive. That means your line has to be above the x-axis. So a positive slope in the graph of f will give you a line that's above the x-axis in the graph of f prime. Okay, and your slope from this point to this point, the line is going down, correct? That means your slope is negative. That means on the f prime, your line has to be under the x-axis. Finally, the line rises again, a positive slope. That means your line in the f prime has to be above the x-axis. So where the slope is positive, line must be above the x-axis. Where it's negative, it must be under the x-axis. Where the slope is 0, it must intersect the x-axis. And that's how we do it. Are these rules clear? Are they? Very good. I hope they're clear. Look, I just did something very simple. This is f, that's f prime. Here the slope is positive. You must draw a line above the x-axis. The slope is negative, and draw a line below the x-axis. The slope is 0. You must intersect the x-axis. That's all there is to it. So, is the function differentiable or not? Just because if the slope is 0, then we intersect the x-axis. So, if the function is continuous, it could be differentiable or possibly not differentiable. If the function is differentiable, it has to be continuous. Okay? So, if you want your function to be differentiable, it must first be continuous, right? That means there should not be a hole. There should not be a jump. There should not be a vertical tangent. Because if you have a vertical line, what's the slope of a vertical line? Do you guys know? A vertical line? What's the slope of it? Infinity. We cannot have that. You cannot have a corner. You cannot have a cusp, which means sharp corner. Such as? That's a cusp. That's a corner. These are both going to be not differentiable. Here we have a vertical tangent, which means the slope at this point is going to be infinity, which is not okay. So it's going to be not differentiable. Okay? So this here represents the slope of the line. The slope is going to be infinity. If the slope is infinity, your graph is going to be not differentiable at that certain point. Okay? Very good. What if you have a vertical asymptote? Again, not differentiable. What x value must be placed in the bottom to make you having a vertical asymptote? -1. This will make the bottom 0, which means at -1 we have a vertical asymptote. Okay? So here's a nice graph where there's going to be a vertical tangent right here. It's like a vertical line. So what's a vertical tangent? I want to draw a tangent line. It's going to be vertical. The slope of vertical line is what? Infinity. So it's not differentiable at x equals 0. Because having an infinity slope means a not differentiable equation. Okay? So having infinity slope means not differentiable. You see, a hole means not differentiable. A jump means not differentiable. A vertical asymptote, not differentiable. A vertical tangent, not differentiable. A corner, not differentiable. And a cusp, not differentiable. Let me ask you about this jump. From which side does the limit? First of all, are the limits equal to each other? Okay. Are they? No, they're not. Let's say here it's cn1 and here it's cn2. So in jump, left hand limit is not the same as the right hand limit. Not the same. Why do you think there's a hole here? Because there's no equal sign. Either bigger than or less than. Why is there a dot here? Because of the equal sign. Bigger than equal to, less than equal to, or just equals. Here there is a hole, but the lines are connected. That means that left hand limit is equal right hand limit. But there's a hole, so it's not differentiable. Okay. The slope here on the left of C, is it positive or negative? Negative. How about on the right? Positive. Because the slopes are different at the corner point, we're going to have non-differentiable equation. And the same thing goes here. Negative versus positive. They're different at this point, which means not differentiable. Is there a hole in figure 8? Is there a jump? Is there a vertical tangent, vertical asymptote, corner, cusp? None. So it's going to be differentiable. At x equals a. Is that differentiable here? That's a cusp. That's a cusp, which means not differentiable. Okay. So sometimes your function is going to be continuous, but it's not going to be differentiable. For example, the absolute value. I want you all to use Desmos and a graph f of x is equal to x and the absolute value. Let me know what graph you will get. Let's see your graph. So we're going to say absolute value of x. You see? It's continuous. Okay. All the values are okay. So we have here a continuous function. There is no hole. But it's not going to be differentiable because here the slope is negative. The slope here is positive. It's not differentiable at the point where the corner is found. So it's not differentiable at x of 0. Now, let's do this in a math way without a graph. So take the absolute value. One time it's going to be x. One time it's going to be minus x. It's x when it's bigger than 0, negative when less than 0. So what's the slope here? Positive 1. What's the slope here? Negative 1, which is why it's not differentiable. Because your left hand derivative is not the same thing as your right hand derivative. Because right hand it's 1, left hand is negative 1, not the same as each other. Okay? Very good. You're doing great. So, okay. So I want you guys to know that when you learn the differentiation rules, if you have x, it will always become 1. If you have negative x, it will always become negative 1. So we're going to say that left hand derivative is not the same as the right hand derivative. Left hand and right hand are not the same. So f prime does not exist, which means not differentiable. Okay. Let's see if you guys can solve this question. I'm asking for the function. I'm asking for the derivative. I'm asking for the value of the derivative. So guys, look. That is our function right here. Or this one. So the numerator. So imagine if we just said limit of h approaching 0. Okay, a plus h to the power of 4 minus a to the power of 4. So our function is going to be this guy. Just replace the a with x. Our function is going to be x to the power of 4. That's our function. If this was a power of 5, power of 5. You guys get the idea, right? Always look at the one that's alone to make your life easier. Okay, now, what is our derivative? Let me teach you some differentiation rules. So if you have x to the power of n, when you differentiate, the n has to go down. X remains. Now it's going to have a new exponent, which is n minus 1. Okay? So if we have x to the power of 4, the 4 goes down, x to the power of 3. Now, how much is our x? 2. So instead of x, put 2. What's 4 times 2 cubed? What's 2 cubed? 8. 4 times 8 is? And that's about it. You guys did it. Let's move on to question 5. Very similar. You guys can pull it off. So look guys, the function here is going to be limit of h approaching 0. Okay, x plus h under the square root minus x under the square root over h. Now the question is actually tricky because one time it's a 9, one time it's a 3. Why? Because when x is 9, what's the root of 9? That's why there's a 3 in here. So right now our x value is going to be a 9. And our function is x under the root. So, you guys told me earlier that x square rooted means x to the power of half. Let's differentiate. Bring the half down. And what's half minus 1? Negative half. Negative half just means bringing the x under the fraction and placing it within a square root. That's our derivative. What was our x value? 9. So,
It's a 9.
sorry?
Why can't it be 3?
No, see, it was 9 here. It's 3 because we already square rooted the 9. So 1 over 2 root 9, 1 over 2 times 3, 1 over 6. How easy is that? It's too easy that it's hard. Let's move on to question 6. So if you want to get the graph of f prime from the graph of f, we have to find the slope. So, okay. All right, so look, here the slope is how much?
0.
Exactly, which means intersect the x-axis. How about here?
0.
Thank you. Now look, we're going down. That means what? A line under the x-axis. We're going up. Meaning what? A line above the x-axis. Oh, by the way, also a zero slope in here, right? So if you go up above the x-axis, if you go down below the x-axis, if you go up above the x-axis. This is the graph of f. That's for f prime. Good? It's very simple. I don't know about you guys, but is it simple? Okay. Let's move on. Let's now do question 7. Let's see if you guys can do question 7. So look, if it's an absolute value, it's one time negative and it's one time positive, right? Left hand limit negative, right hand limit positive. What number do I place instead of the x so the whole thing on the inside becomes 0? 2. So the limit of x approaching 2 from the left, we're going to find it. And also limit of x approaching 2 from the right, we're also going to find it. Okay? So, do you guys recall this equation? Limit of x approaching a, f of x minus f of a over x minus a. You guys recall that from last time? If you don't, it's okay. Just memorize it next time. So, f of x is going to be negative x minus 2 minus f of a means you replace the x with 2. So minus, okay, negative. Instead of x, put 2. Over x minus 2. And for the approaching 2 from the right side, we'll just put x minus 2 minus, instead of x, put the 2. So 2 minus 2. Over again, x minus 2. You see, guys, for the left-hand side, I put negative. For right-hand side, there is no negative. Okay? Would you guys like to continue that? Rest is simple algebra. So we're going to get negative x minus 2 over x minus 2, which means negative 1 from the left. We'll get x minus 2 over x minus 2, which means 1 from the right. Are they equal to each other? No, which means not differentiable. So this whole thing was called left-hand derivative. This whole thing was called right-hand derivative. They are not the same as each other, which means not differentiable at x equals 2.
What's the difference between
Left-hand limit and derivative, not the same thing. We use, look, this formula here, even though it has limit, I'm finding derivative. Okay? So look, if you were to use this form, or if you were to use this form, They're both used to find derivatives. They both mean the derivative. Okay. Let's now move on to something else. Let's go back to the book. So guys, if you see f prime x, or if you see y prime, or if you see dy over dx, they all mean one thing, which is the first derivative, or we can just call it derivative. Okay? But if you see f double prime, or if you see y double prime, or if you see d squared y over dx squared, we're discussing the second derivative. All right? So, let's teach you some rules. So if I have x to the power of n, it's going to become n x n minus 1. That's the most important rule. Okay? The most important rule is this one. Okay. Let's do an example from the book. So here we have f prime of x is equal to 3ax squared minus 4x plus 1, x less than or equal to 2, minus 4x cubed plus 8ax minus 5, x is bigger than 2. They're saying find the value of a, okay, to make f differentiable at x equals 2. Go ahead. Start working. So differentiable means left-hand derivative is equal to right-hand derivative. Less than means left-hand derivative. Bigger than means right-hand derivative. You see f prime, which means derivative. We must now equalize them to each other. So I'm going to say 3ax squared minus 4x plus 1 is equal minus 4x cubed plus 8ax minus 5. Instead of x, put what? 2. Because of 2. So 3a 2 squared minus 4 plus 1 is equal minus 4 2 cubed plus 8a 2 minus 5. So we're going to have 12a minus 8 plus 1 minus 4 times 8, negative 32, plus 16a minus 5. So 16a minus 12a, 4a. Put all the numbers on the left side. So minus 8 plus 1 plus 32 plus 5. So 4a is equal to, what's negative 8 plus 1? Negative 7. Plus 32, 25. Plus 5, 30. So a is equal to 7.5. Good? Any questions? Okay. Do you guys have the book? If I say go to this example or that one? Not yet? Okay.
I think yours is different from ours.
So let's look at this example. Y is equal x to the power of 5. Let's now differentiate. So we're going to say y prime is equal to, the 5 has to go down. because x to the power of n is n x n minus 1. Bring the 5 down. What's 5 minus 1? 4. Okay. Other example, y is equal to x to the power of 20. Differentiate. Bring the 20 down. X to the power of 19. Are we clear so far? This is hard.
No, it's not like this. I need to process it.
Is it hard?
No.
Okay, very good. Y is equal to x to the power of negative 5. You guys tell me how to do it. Goes down. Yes, because negative 5 minus 1 is negative 6. Yes? Okay. Y is equal to x to the power of third. Bring the third down. And ask yourself, what's third minus 1?
Negative. So,
Third minus 1?
third,
Guys, 1 over 3.
and negative 1. And negative 0.33.
Negative 2 over 3. Now guys, if I have x to the power of 2 over 3, open a root, okay? The 2 goes on the inside, the 3 goes on the outside. What if I have x to the power of negative 2 over 3? The same thing, but under 1. So x squared to a cubic root. Okay? How about y is equal to x? How do you differentiate that? Okay, what's the power right now on the x?
1.
You bring it down. 1 minus 1 and minus 1. So 1. Whenever there is x, it just becomes a 1. Whenever there is 2x, it becomes a 2 times 1. Okay. And whenever you differentiate a number, the y prime becomes 0. Always. Okay.
So I think you skipped 2 pages.
Oh, no. We're fine. Let's see if you guys can do this other example. Y is equal negative 3x to the power of 4. Go ahead. Negative 12x to the power of. Very good. How about y is equal to 12?
0.
Exactly. Okay. Let's do more. Y is equal to 3x to the power of 4 plus 8x to the power of 10. Let's find the y prime.
12x to the 3rd power plus 80x.
Excellent. Not too hard, right? Okay. Let's now use letters instead of numbers. So y is equal ax cubed plus bx squared plus cx plus d. Find the y prime.
Plus 2bx plus c.
And d becomes 0 because d is just a number. Okay, let's talk about the derivative of pi to the power of 5. What's that going to be? Each one of you gets one try, starting with you.
5 pi power 4.
Wrong. Not answering is also wrong.
0?
Hmm?
0.
Yes, 0. Pi is just a number. Okay. Let's now do something else. If I have sine upon differentiation, it becomes cosine. If I have cosine, it becomes negative sine. Okay? If I have ln of x, it becomes, so you see the x, it will go on the bottom. On top, differentiate the x. So what's the derivative of x? 1. How about y is equal ln x squared? Bring the x squared down. On top, differentiate the x squared. Which means what? Now simplify it. You get 2 over x. So in ln, you will always have x in the bottom. Always. That will never change. And the power is the number on top. Power is 1, you get 1 on top. Power is 2, you get 2 on top. Okay? Let's see if you guys can do ln x to the power of 3.
3 over x.
Sorry? 3 over x. Do we agree? The power goes on top, and the bottom will always have x. No exceptions. Okay, but now it will get complicated. Y is equal to ln 5x minus 3x to the power of 6. Let's find the y prime. First thing you do is copy paste everything you see next to the ln to the bottom of the y prime. So 5x minus 3x to the power of 6. On top, differentiate it. Differentiate what you see next to the ln.
So 5 minus 3, no, minus 18.
Exactly. Very good. If I have f of x is equal ln cosine x, what's the f prime? First,
Negatives.
put the bottom as cosine. Second, differentiate the cosine. Negative sine. What's sine over cosine? Tangent. So, negative tangent.
So less negatives.
Sorry? Oh, cosine is always negative sine when you differentiate. Always. It's a rule. Okay? Let's give you more rules. So, if I have y is equal e to the power of x, you will first copy paste it, and second, you will multiply it by the derivative of this one. So what's the derivative of x? 1. Which means e to the power of x. Yes? If y is equal e to the power of x squared, differentiate. The first thing you do is you must copy paste it, then multiply it by the derivative of x squared, which is 2x. This is hard. You don't have to lie.
So the first one is the same?
Yeah. But once the x has a power that's more than 1, things will change.
So sir, what's the result?
That's the result.
That's the result?
Yep. What if we have y is equal to e to the power of 2x? Now differentiate. Y prime is equal to. You copy paste it and do what? Multiply by derivative of 2x, which is 2. Good. You guys are learning. Are you? I'll give you some questions. Let's see if you guys can get them by yourself. Don't give me that look of confusion. You will do it. Grab the pen. So first thing is you have to copy it. Copy paste it. Second, multiplied by the derivative of the power,
Okay.
which is 3. Copy paste,
Yes.
multiplied by 3x squared. Copy paste.
So y squared.
What's the derivative of tan? It's new. It's secant squared.
So y2. Y squared. So
I didn't make the rule. Let's learn something called the quotient rule, which says if you have a over b, it will become, open a fraction, b gets squared, b times a prime minus a times b prime. That's called the quotient rule. So, let's take tan. Tan is equal to what? Sine over cosine. Let's now differentiate. We must apply the quotient rule because we have fraction. So, b squared, that means cosine squared. Cosine times a prime. So look, a is sine, b is cosine. What's a prime? Cosine. What's b prime? Negative sine. So b times a prime. Okay, so b times a prime minus a times b prime. So sine x with negative sine x. Okay. Now what's cosine times cosine? Cosine squared. What's negative with negative? Positive. Sine squared. Cosine squared plus sine squared, you guys have to know, is equal to 1. Now, what is secant? 1 over cosine. How about secant squared? 1 over cosine squared. So, would you like to just memorize it? Tan becomes secant squared when you differentiate. And that's about it. Okay? Now, let's give you another rule. So, if y is equal to a to the power of u, a being a number, its derivative is going to be, you copy paste it, you differentiate the u, then times it by a ln of a. Okay? That's the rule. For example, if I have y is equal 5 to the power of x, y prime is equal to, copy, paste it, times it by derivative of the power. So what's x differentiated? 1. Ln of 5. Simplify. 5 to the power of x times ln of 5. Okay. Let's see if you guys can do this one. Y is equal to 3 to the power of x squared. Go ahead, differentiate. Copy, paste it. Multiplied by derivative of the power. Then by ln of the number. And that's how you do it. You leave it like this. Now, let's teach you something called the product rule. So if you have a times b, it equals to, upon differentiation, to a prime times b plus a times b prime. Okay? So, for example, if I have f of x is equal to e to the power of x squared, I want you to find the first derivative followed by the second derivative. Do you guys want to try it? Okay. First, copy paste it. Then multiplied by derivative of the power. Now here we have two terms. We have the a term, we have the b term. You must do a times b prime plus a prime times b. So a times, so look, a is 2x. b is e to the power of x squared. What's a prime? Derivative of 2x. What's b prime? Derivative of e to the power of x squared. So a times b prime and then we have a prime times b. Let's now simplify and factor out e to the power of x squared, 4x squared plus 2. I'm going to act like you, just gazing. Come on, guys, let's have a goal. Okay, let's do more rules. Since you guys don't mind, it seems like, right? No one's talking, so that's a sign of acceptance. Okay. So if y is equal to log, the base of log being a, log of u, y prime is equal to, on the bottom, put u times ln of the base, on top put du. It's another rule that you guys have to know, like very well.
And we have to memorize the algebra by 30 rules.
Yeah. I mean, look, you have
Like cosine.
you have like
sine.
10 months before the exam.
Yeah.
Almost, let's just say 9. Can't you know 50 rules in 9 months? Each month, 20 rules. That's less than 1 per day.
It's better than like
Okay.
a subject.
Each month, 30 rules. Each day, 1 rule. You can finish in a month and a half.
We're gonna forget by the end of.
Review it for the next 7 months and a half.
You can solve practice questions.
Of course.
So you're not forgetting.
Okay, let's do log of base of 5, 3x squared. Show me the magic. Get me the y prime. By yourself. Don't ask anyone for help. She's not doing anything. Do something. So 3x squared becomes 6x upon differentiation over u, 3x squared times ln of a, ln of 5. How easy is that? Let's see if you guys can do... So look, if I say d over dx, that means derivative. Find d over dx of ln 5x. Yes. D over dx means derivative. Would you like to use that pen more? Both of you? We have plenty of pens. It's fine. Just use them. Sorry? Copy paste the 5x in the bottom, on top differentiated. Excellent. You're trying a lot. Okay, let's see if you guys can do d over dx, 3 to the power of x squared. This is basically a to the power of u. If you guys recall, it was au, ln of a, or du then ln of a. You guys recall that? Do it. So it's going to become 3x squared times 6x or times 2x. Derivative of x squared times ln of 3. So 6x cubed times ln of 3. We like it. It's pretty easy. Let's now do d over dx of 3 to the power of x.
Sorry, could you go to this? Alright, thank you.
Yeah. So copy paste it times 1, the power, right, becomes a 1. When differentiate, ln of 3, remove the 1. Pretty easy. Pretty easy. Okay. Let's see if you guys can handle this one. D over dx log base of 10x. So copy paste the x in the bottom multiplied by ln of 10. On top differentiate the x, which is a 1. Let's now do d over dx log, whose base is 8, x squared plus x.
Both of the x's u or
U is x squared plus x. So copy paste the u in the bottom multiplied by ln of 8. On top, derivative of x squared plus x, which is 2x plus 1. Perfect. We're killing it. Oh, you guys will like this one. D over dx log, whose base is e, x. So first, copy paste the x, then ln of e. On top, differentiate the x. Now, ln of e is equal to 1, you guys have to know. So 1 over x. Okay. Yep. Very good. Let's now do d over dx for 8 to the power of 4x squared. So this reminds me of 8 to the power of u, which becomes copy pasted du times ln a. So copy pasted times the derivative of the power, then times ln of 8. Easy. Oh, you guys will like this one. Pi is just a. It's like a 5 or a 3, same thing. So go ahead. So copy paste it, multiply by derivative of sine, then ln of pi. Very simple. Oh, this one is hard. This one is hard. So look, essentially, we're looking at f of x is equal to x to the power of x. Let's now apply ln to both sides of the equation. So we're going to have ln f of x, ln of x to the power of x. Now, do you guys know about some ln properties? For example, if I have ln a to the power of b, b has to go down. So what's the b here? X. So we're going to say ln f of x is equal to x ln of x. So x times ln of x. So far we have not done any differentiation. Now it's time to do it. So to differentiate ln, you copy paste what's inside in the bottom, on top differentiate it. So f prime. And here you have a times b. It doesn't matter. It doesn't. For the product rule, it does not matter. But for quotient rule, it does. What was the product rule? A times b prime plus a prime times b. So a is x. B is ln of x. A prime is 1. B prime is 1 over x. So a times b prime plus a prime times b. Okay, that's the product rule. Let's now simplify. So we're going to have f prime of x over f of x is equal to 1 plus ln of x. And now it's time to cross multiply. So we're going to have f prime x is equal to f of x times 1 plus ln of x. Let's recall what f of x was. It was x to the power of x. Okay? So instead of that, put x to the power of x, 1 plus ln. And now simply distribute. So x to the power of x plus x to the power of x times ln x. Or you could just leave it like the first one. Both correct. How easy is that? So, let's now do the derivative of this function. First, you copy paste sine x to the power of 5. And then on top, differentiate sine x to the power of 5. So, what's the derivative of sine? Cosine. Put this here, cosine. Then, what's the derivative of x to the power of 5? Power of 4. You see, I do them separately. One time I differentiate the sine part, one time I differentiate the x part. Okay? That's called the chain rule. It's a chain. Beginning to end. Okay.
That's it.
You can leave it like this. But, can someone tell us what's cosine over sine?
One.
Not tan. Cotan. So cotan x to the power of 5.
What is cosine?
1 over tan. So if tan is sine over cosine, cotan is cosine over sine. If tan is sine over cosine, cotan is the opposite. So there is no equation sheet in the calculus.
Actually,
Everything. Let's now do f of x is equal e to the power of 3 x to the power of 7 minus 4x squared. Let's find the derivative. First of all, copy paste whatever you see. Then multiply by the derivative, which is 21 x to the power of 6 minus 8x. Exactly. Okay. Let's now find log for tan x. Let's find its derivative. Okay, so first we copy paste whatever is inside the log in the bottom, multiplied by ln of 4, which is the base of log. On top, differentiate tan to become secant squared. That's about it. Very easy. Okay. Let me teach you a new log rule. So if I have log of a over b, it means I have log of a minus log of b. With that in mind, do the following question. Y is equal to log of base of 8 root of x cubed over 1 plus x cubed. Go ahead. Find the y prime, please. Also, don't forget this rule. Log of 8 to the power of b is equal b times log of a. So, can someone tell us, when you see a square root, what power is that? Half. So log 8 x cubed 1 plus x cubed, the power of half. Y. So far we have not differentiated anything. Okay? Now what? Because of the log properties, I'll bring the half down. Because of log properties, I'm going to do numerator log minus 1 plus x cubed log. I have not taken the derivative yet. I'll leave that to you. Sure. So look. Right now here we have log of a over b to the power of half. Okay? A is the top, b is the bottom, the power is half because our root means half. Bring the half down. And now log a over b means log a minus log b. And now it's time to differentiate using the log rules. The half stays the same. Differentiate on the inside. So open a fraction. On the top, differentiate. So 3x squared. On the bottom, x cubed times ln of 8. 3x squared. Because what's the derivative of 1? 0, right? On the bottom, 1 plus x cubed times ln of 8. That's how easy that is. Most likely stop. I mean, FRQ won't ask you this. MCQ will. So you're gonna have choices to choose from. Okay. Let's now do y is equal to 5 to the power of root of x. Find the y prime. First of all, copy paste what you see. Second. Okay, then we're going to differentiate root of x, so 1 over 2 root x, then ln of 5. Always memorize that root of x differentiated is 1 over 2 root of x. So y is equal to e to the power of x to the power of 5 over 5 tan x. Go ahead and differentiate using the quotient rule because you have a fraction. So look, y prime is equal to, you must apply the quotient rule. What's the a term here? The one that's on top. What's the b term? On the bottom. So a prime is equal to, you copy paste it, multiplied by 5 x to the power of 4. B prime is equal to, you copy paste it, times it by the derivative of tan, which is secant squared, then ln of 5. So, what's y prime? B squared goes in the bottom. B times a prime minus a prime times b. And yes, you may leave it like this. Let's see if you guys have energy for this one. You guys will like this one. X squared plus 7x, x to the power of 5. Go ahead and find derivative. Go ahead. So, b squared, b on top, times a prime, minus b prime times a. Just know the sequence, please. And just leave it like this. How easy is that? F of x is equal to x cubed minus 3x to the power of 4. Here we have x squared plus 7x. You must differentiate this using the quotient rule because we have a fraction here, right? So what's the a term? What's the a term? The numerator. What's the b term? Denominator. So a prime is equal to 3x squared minus 12x cubed. B prime is equal to 2x plus 7. So f prime is equal to b squared goes in the bottom, which means x squared plus 7x squared. B times a prime minus a prime and minus b prime times a. And that's how we do it. We'll just leave it like this. Okay. Let's do another one.
So what's the purpose of the prime?
Prime means derivative.
So what do we do with it? Do we just not write it?
What do you mean, like inside? What do you mean by, okay, what do you mean by that? So look, if you have a to differentiate, that means a prime. B is b prime. All right, guys. Find the y prime here. So the a term is the top. B term is the bottom. A prime is equal 3. B prime is equal to 5. Let's find the y prime. So on the bottom, put b squared, which means 5x minus 3 squared. On top, put b times a prime minus b prime times a. We can now simplify it. So 15x minus 9 minus 15x minus 25. Okay? Y prime is equal to, what's 15x minus 15x? It's gone, right? Negative 34, 5x minus 3 squared. Okay? That's how we do it. Okay. Let's do more. F of x is equal to sine x over cosine x. Find f prime. Quotient rule. So what's the a term? Sine. What's the b term? Cosine. So the derivative of sine is cosine. Derivative of cosine is negative sine. In the bottom, put b squared. B times a prime minus b prime times b. Okay. So f prime is equal to cosine squared plus sine x. I think I made a mistake. Wait. B prime times a. Yeah. So plus sine squared x over cosine squared x. What is cosine squared x plus sine squared x equal to? 1. What's 1 over cosine? Secant. But it's cosine squared, so we'll get secant squared. Super easy. Okay. Let's now try the reciprocal. Let's try to differentiate cosine x over sine x. Go ahead, differentiate. So the a term is cosine. The b term is sine. A prime, negative sine. B prime, cosine. So f prime is equal to b squared goes in the bottom. That means sine squared x on top b times a prime minus b prime times a. So we're going to have negative sine squared minus cosine squared over sine squared. So far, right? But I'm not done yet. Can I factor this negative from the top of the equation or the fraction? Could I? Can I factor it out? So we're going to have sine squared x plus cosine squared x over sine squared x. Who knows what sine squared x plus cosine squared x should give me? 1. So, negative 1 over sine squared. What's 1 over sine? Cosecant. How about sine squared? Cosecant squared. So we're going to have negative cosecant squared x. Okay. Let's now differentiate this one. 1 over cosine x. So a is 1, b is cosine, a prime is 0, b prime is negative sine. So f prime is equal to b squared in the bottom, on top b times a prime minus b prime times a. So we're going to have sine x over cosine squared x. Now, that's the same thing as having sine x over cosine x times 1 over cosine x. Who knows what 1 over cosine should give you? Secant. How about sine over cosine? Tangent. Okay? That's the answer. So you guys have to know that 1 over cosine is secant. You guys have to know that. That's like normal math. And sine over cosine is tangent.
A part before
Mm-hmm.
the sine over cosine squared x.
Mhm.
Not the. Oh yeah.
Mm-hmm. So guys, look, learn the following. Actually, one more. Then I'll give you some rules. Do the f prime. So a is 1, b is sine. So a prime is 0, And b prime is cosine. In the bottom, put b squared sine x, so b times a prime minus b prime times a. So we're going to have negative cosine x over sine squared x, 1 times sine x, and 1 time 1 over sine x. Okay? So if sine over cosine is tangent, how about cosine over sine? Cotangent. So we're going to have negative cotangent x. What's 1 over sine? Cosecant. Okay? Now, let me give you some rules as a summary. The derivative of sine is what?
Cosine.
Exactly. Your turn. Derivative of the cosine. Right. Very good. Derivative of tan secant squared. The derivative of secant, right, so secant tan. Okay. How about the derivative of cosecant? Minus cosecant cotan. Know these, please. They're very important. Okay? You guys will receive a test from me in the weekend. Now, that test has to be timed, and you have to do it with honesty. Yes. I'm going to grade it for you, because your parents have to know. If they ask me, they have to know where you are right now. That's if I ever get to talk to your parents. I don't see the parents of most of my students, but maybe your parents, I'll see them. You never know. Okay. You still need... Now there's something new called the indeterminate form. What does that mean? It's when you replace x with a certain number, you end up with a 0 over 0 or infinity over infinity. That's what it means. That's not okay. This is not acceptable. You have to avoid this at all cost. So what you do instead is that to avoid this, you have to apply the L'Hopital's rule. Okay? This only applies for a rational function, which means a top and a bottom. So how would you do this? By taking the derivative of the top and the bottom without using the quotient rule. Without. You must do each one of them separately. Okay? For example, here, look at this one. Limit of x approaching 0 for sine x over x. Right now, if I replace the x with 0, what do I get? I get sine of 0 over 0. How much is the sine of 0?
0.
0. Is having 0 over 0 okay? No, not okay. Must be avoided. You must avoid it. So how? You must apply something called the L'Hopital's rule, meaning you must differentiate the top and the bottom without using the quotient rule. Separately, right? So, what is the derivative of sine? Cosine. How about x? When you differentiate x, what do you get? Who said 1? Okay, good. Now, what's the cosine of 0?
0.
1, actually. You get a 1. You were able to avoid having 0 over 0. The answer became a 1 by using the L'Hopital rule. Good? If you guys recall, we took this in the first unit. It was a rule. Do you guys recall? First unit? This was a rule. That's the proof of why we got 1 in the first place. Okay? Very good. Let's see you guys take care of these limits. Right now, if I put the 3, I'll get 3 squared minus 9 over 3 minus 3. 0 over 0. Not okay. Please take care of it using the L'Hopital's rule. So differentiate the top and the bottom separately. Thank you. It's going to be, so you're going to write limit, x approaching 3, 2x over 1. Apply the 3. You get 6. Good. Very good. Here, if I put the 0, I'll have tan of 0 over 0, which means 0 over 0, which is not okay. So don't do that. And instead, apply the L'Hopital's rule. So go ahead, solve it. So look, tangent becomes secant squared upon differentiation. And x becomes 1. Now, what exactly is secant squared? 1 over cosine squared. One over cosine squared. What's the cosine of 0? 1. What's 1 over 1? Just 1. So we saved the equation from being 0 over 0. We got a 1 as the answer. That's good, right? Using what? Using the L'Hopital's rule. Excellent. There is something new called the chain rule. So the chain rule says differentiate the outside, then differentiate the inside. So f is the outside, differentiate first. G is the inside, differentiate last. For example, if I have cosine cubed, what do? If I have cosine cubed and I want to differentiate it, use the power rule, which means what? Bring the 3 down and make it 3 minus 1, which is 2, correct? Then differentiate the cosine. What's that going to be? Cosine derivative. Minus sine. And that's my answer. Okay, look, let's do another one. Let's do sine squared x. Differentiate. First, apply the power rule. What does that mean? Bring the 2 down, minus the power by 1. So it becomes 1. Then differentiate the sine, which becomes cosine. And that's about it. Yeah. Have you guys heard about the derivative of the absolute value? It came out this year. It's a new rule. So, if you want to differentiate, this means derivative or differentiate, the absolute value of x plus 1, you will simply copy paste that absolute value in the bottom of the fraction. On top, put it without the absolute value. That's a rule. For example, okay, so look, if you have an absolute value, put it the same way it is in the bottom. On top, copy paste without the absolute value. And that's about it. It's very simple. Get it? Very good. Who recalls what the IVT was about? The intermediate value theorem. What was the requirement for the function to be in the IVT? It had to be continuous. How about the MVT? It has to be continuous and differentiable. It has to be continuous on a closed interval, but it has to be differentiable on the open interval, which means not including the endpoints. Okay? At this point, the slope of the function is equal to the slope of the tangent line. What does that mean? For example, if I were to draw this curve and I draw a tangent line like this, secant line. That's called a secant line. I'm going to have a tangent line with the same exact slope at least one time. That's called secant line because I am just touching the red curve from the outside, like barely touching it, like this. That's called secant line. Tangent line. So they're going to have the same slope according to the MVT. MVT says if there is a secant line whose slope is 5, there is at least one tangent line with the same exact slope. At least one. At least. See? At least one. Okay? So look, the average rate of change is calculated by doing y2 minus y1 over x2 minus x1 will be equal to the first derivative, which is the f prime. F prime is also called the instantaneous rate of change. The question now is, what exactly is a differentiable equation? You must always have continuity at all points, no vertical tangents, no cusp, no corner. Then it's called a differentiable function. Only then. Okay? So let's compare IVT to MVT. Continuous versus differentiable, closed interval versus closed, and also open. Closed for the function, but open for the derivative. Okay? This is the equation of the slope. y2 minus y1 over x2 minus x1. The slope is equal to the derivative. Here is just bigger than, less than. We don't have that in the MVT. We just have, look, we have the first condition, but then a different second condition. Are you getting that? Okay. Can someone tell us where the secant line here is? We have 3 lines. 1, 2, 3.
That's the peak of the cube.
Yes, it has to cut through the graph. Cut through it. So line 2 is the secant line. How about tangent lines? Yep, they touch on the surface. 1 and 3. Line 1 and line 3 are both tangent lines. MVT says the tangent lines will have the same slope as the secant line. So if the slope of line 2 is 2, they're going to have the same exact slope of 2 as well. Slope of the tangent line is called the derivative. Slope of the secant line, which is the PQ, is basically f of b minus f of a over b minus a. Same slope. All right? It's very important. Oh, AP question. This is a good example of what your exam will look like on the weekend. Go ahead. Take your time. So, we're looking at v prime. V prime means what? Your function is differentiable. Prime means what? Differentiable. And guess what? It is differentiable. So, the time ranges from 0.3 to 2.8. Okay, so the time ranges from 0.3 to 2.8. I want you right now to find, look, let's call this A and let's call this B. Fair enough? A is less than B. So you're going to say A is equal to 0.3 and B is equal to 2.8. So F prime C, where C is bigger than 0.3 but less than 2.8. So let's say maybe C is 1, maybe C is 2, maybe C is 2.7, right? Then F prime of C is equal to, you will do F of B minus F of A over B minus A. What's B, what's A? B is 2.8. And what's A? 0.3. F prime of B, so 55. I mean FB, which is 55. What's F of A? Uh-huh. How much do we get? 0. And they want the V prime to be 0. We just did that, right? So V P prime T is equal to 0 on the interval of C bigger than 0.3 but less than 2.8.
Can you repeat this first?
Which part?
The one after that. 2.8 minus 0.
Yes, because look, the equation for the F prime is going to be y2 minus y1 over x2 minus x1. This is your x1, this is your x2. x2 minus x1 goes in the bottom, y2 minus y1 goes on top. This is the y1
How do we get 0?
because you're going to have the same number minus itself on top. The whole thing becomes 0. Okay? Whenever you answer these questions, always mention the theory name. In this case, do we say IVT or MVT? MVT. Why the MVT? Yep, mean value theorem.